Hi, friends. I'm Ned. When I'm not exploring the mountains, I'm passionate about DevOps, software development, and security. This video is a companion to my blog post at nedmclean.com on object recognition for non-developers. Sort of a mouthful, I know, but it's a really exciting time in the evolution of machine learning because these powerful tools are no longer just in the hands of Python developers like myself. They've really been democratized. And without a line of code, whether you're in sales or healthcare, project management, finance, you name your industry, you can apply machine learning to make a difference in your business today. In this video, we're going to train a custom neural network model to identify novel objects in images. These are objects it's never seen before. And object recognition is generally a really well understood application of machine learning. And that's why it's one we can use our feet to get wet with and get familiar in just a few minutes with how machine learning works. Object recognition has been applied to defects, finding defects in manufacturing, or keeping self-driving cars from hitting pedestrians or bikes, or what road signs they see, or finding tumors in x-rays, or dozens of different applications for object recognition. It's probably something that could be applied to your industry today. This video takes about 10 minutes of effort, but there are several places you have to wait on the computer. So if you're following along in real life, don't hesitate to use that pause button. Let's get started. Okay, the first step is to navigate over to Supervised.ly because we're going to be using the Supervised Li platform for our entire computer vision lifecycle. It's worth noting I have no affiliation with Supervised Li. I've used Amazon SageMaker quite a bit, and I feel like Supervised Li is just a great way to get your feet wet without having to learn a lot of new concepts. And so we're going to get started with signing up, and there's a free account. Go ahead and create that account, and when you're logged in, you'll see the Supervised Li dashboard. First, we'll click on Workspaces, and then dive into the workspace that was created for us. And normally you'd upload images here and annotate them yourself. We're going to cheat a little bit and use Supervised Li's datasets library, which includes a set of annotated rows. There's 10 images in that dataset. Later, we're going to test our trained neural network with the test dataset, which has 156 images. For now, I'll add the annotated dataset to our project and view it in our workspace. When we drill into the dataset, the annotation tool comes up, and we can see where these big yellow tags have been added to the image, demonstrating that's a road. If we had to annotate the images ourselves, it's actually pretty easy for object recognition. You might say person or something, and then you would draw over the image a box. I should have named that a tree. But you can see that annotation is a pretty easy task. It is definitely time and labor intensive. We can't actually do anything with our annotated data until we bring our own server to Supervised Li. And that just means we need to provide a GPU-enabled server that meets these requirements. Amazon AWS is a great, easy way to do that. It's also possible to do with GCP or even a GPU-enabled server under your desk. We're going to copy this configuration snippet here and log into our Amazon console. Once you're logged in, we'll click on EC2 to get an instance launched. It's important that we pick an Amazon deep learning image so that we meet all of Supervised Li's requirements. There's also a Supervised Li image that I'm not as familiar with. We've selected our image, and we're going to need to customize a couple options, including making sure we have a GPU-enabled instance, and we're going to pick the cheapest one that meets our needs, P2 extra large. We also want to make sure to request a spot instance so that we're paying 10% of the regular $3 cost here. And we lastly need to specify user data. We're going to make sure that Amazon knows this is a bash script, and then we're going to paste in the bash script contents, that configuration that Supervised Li gave us. We'll need to add a bit more storage to deal with a large data set. It was too much. How about 200 gigs? And our security group does not need external SSH access, so this will be a secure host. We're going to review and launch and pick our SSH key, confirm we have access to it, and request our spot instance. Now, we may not get our spot instance. This is an open marketplace, and so we'll check to see. Our active request has been fulfilled, so that's good news. We'll go to our instances, and ignoring a previously terminated instance here, we'll see that our new instance is pending and booting. We're going to need to wait a few minutes here, and when it's ready, we should see it appear in the Supervised Li console, waiting for a signal from the agent. Once your server is booted, it should show up in the Supervised Li cluster console as running. It takes 5 to 10 minutes to load all the Docker containers, so be patient. You can drill down and see details about the server, including the Tesla K80 really is in there. So that's good news for us. Now we can go back to our project. We have to do one more step before we can actually train our neural network. You'll remember we only have 10 images in our data set, and that's nowhere near enough to train a network. We need hundreds or thousands. Fortunately, Supervised Li gives us a quick solution to that problem. Their data transformation language. Let's run one from scratch. And we're not going to actually type in the transformation information. I provided a sample DTL for this project, and it's linked to in the description of the video. Let's grab it, copy, and paste it into the DTL editor. On the right, we can see that Supervised Li gives us a visualization of what's actually going to happen to our images. And just for example, some of the images will be flipped, some will be randomly cropped, some will have brightness and contrast adjustments. And then ultimately, they'll be split and tagged into either training data or validation data and saved in a new project. Let's run this DTL and see what happens. We're going to want to pick our agent because it's going to run a lot faster, and we'll hit start. We can see the task running in the Supervised Li tasks console, and we'll watch that happen for a few seconds. I'll fast forward through this part for the video, but know it takes a few minutes to accomplish this. And with that task complete, we're ready to train our neural network. If we go back to our projects, we'll see our output project just was created. And it's got 1,320 images split between training and validation that the network will use together to optimize its model. Let's click on the Neural Networks tab and add a new one. There's a ton of choices here and a lot of discussion to be had about neural networks. We're going to pick YOLO v3. You only look once, and add it to our project or our workspace. And here we've got a generic YOLO v3 model. We're going to retrain it so it can identify our new custom objects, roads. We'll just click the train button. We're going to pick our input project, which is our augmented train value, and give it a new title, YOLO roads. And we're not going to need to adjust any of these training parameters at this time, although there's lots of room to optimize things. We're going to click run, and we can see our task is being executed on the server. Okay, that took about 23 minutes to train on the Amazon server we provisioned. And when it's done, you can click on this little checkbox to view and manage checkpoints. We configured it or used the default configuration of 5 training epochs. It's possible with many more epochs, we could get a much more accurate model. Nonetheless, we did pretty well here. In fact, our best epoch had a 92.5% accuracy. Not so bad. We could probably use that in a testing environment or maybe in a pre-production environment. Let's go ahead and pick that model because it was our best result and name it YOLO Roads Best. While we're waiting for that process to happen, we can peek at the charts associated with our training and see the training progress over time, that it did get more and more accurate over each epoch, although the validation on the last epoch was not great. And that might mean we have an overfitting problem. These are all things we can tune and optimize in our model, but not something we're going to deal with today. Once our YOLO Roads Best model is complete, we can click on the Neural Networks tab in our workspace to view it. Congratulations! You've trained a custom object recognizer. Our final step in this video is to test it. Let's go back to our projects, and we've got 2 projects so far, but we can add another and then choose the roads test data set, which is 156 non-annotated images provided by Supervised Li. These are all country roads. We'll add that to our project and have it available to run some tests on. Back in our Neural Networks tab, we'll pick our YOLO Roads Best model and try to test it. And this will undergo the process of inference, using the Neural Networks model to infer what objects might be visible in those images. We're going to pick for our input project the test data set. And we're using our YOLO Roads Best model. And we'll pick a new name like test output. We can stick with the defaults here and go ahead and run the process. Once again, inference is going to take a couple minutes, nowhere near as long as training. And when we have our results, we'll check them out. Inference on all 153 of those images took about 1 minute, 12 seconds. Let's look at the results. There's a lot of math and tools we can apply here to determine exactly how good our results are. We're just going to do a spot check to see if it was able to see any roads. Now remember, this test data was not annotated, and before our training, the neural network had never seen country roads before. It looks like the first one was a success. We'll click through just a couple to see if it's identifying country roads. And it is. And that's it for this video. I'm hopeful you're inspired to take machine learning and apply it to your business today.